Hey everybody, it's Mr. Carr again. Today we're going to be looking at 6 day 1, what's called rational exponents. So rational exponents is any time we have an exponent that is as a fractional format. So for example, for so this is our kind of like basic example here. For any real number b, any positive integer n, b to the 1 over n is equal to my n radical of b. Okay, so that n is my index number. So whatever it is. So for example, 27 and 1/3, that's the same as the cube root of 27. Okay. Negative 16 to the 1/2 is the square root. And it's a square root. We don't have to write it, but technically there is a 2 there. Okay. Now the other part of rational exponents is when we have two values that in my fraction, and it's not 1 over something. So for example, for any real non-zero number b and any integers x and y, as long as y is greater than 1, that means b of x over y. My y, the denominator, is still the index. And the x here in my numerator is the exponent inside the radical. Okay? But it's also the same as if I do this. If I take the radical of it first and then just have x as my exponent on the outside. Either one works. Okay? So when we look at this one, it's telling us a little bit more here. If b is less than 0, which means that this number inside is negative, and y is an even value, okay? So if y is an even value, then it's potentially we have complex ones. Like this one right here is a good example of this, okay? Negative 16, that's less than 0. Then I have an even root here like this one, so we get complex values like that, okay? All right, so that's what we're looking at here on these. So again, what we're trying to analyze here, if you have a fraction here, the 2 is going to go on the outside like this. The 3 is my index number. So we're dealing with the cube root of 27 and then raised to the second power. Okay? All right. So let's try some of these out real quick. So my first couple examples, this one's really straightforward. Again, the 7 is going to go on the outside of the square root, and then it's going to be the 7th root of a. Okay? If I want to go backwards of that, remember, I just need to be paying attention to this. My exponent is 1. My index number is 2. So that means this is the same as w to the 1/2 power. Okay. So if we do some of these with these other numbers here, first thing we have is 49 to the negative 1/2. Okay. Since it's to a negative exponent, remember the properties. We can do this as 1 over 49 to the 1/2 power. Well, now I can turn this, because this is my index number, this will be 1 over the square root of 49. I didn't have to put the 2 there, but just demonstrating how that transfers over. So 1 over the square of 49 turns into 1 over 7. Over here, 32 to the 2/5. Now when I do that one, again, this is going to be my exponent. This is my index number. So I'm looking at the 5th root of 32 to the second power. Okay, that's where the pattern goes for those. I can do 32 to the second power first. Okay, I can evaluate this, make it a larger number, and then try to take the 5th root of that. But this problem is probably easier to do it this way. We're going to take the 5th root of 32 first and then square that value. The reason why I want to do that is that I'm dealing with a smaller number with 32 instead of 32 squared. So the 5th root of 32, this is 2 times 2 times 2 times 2 times 2. So I can kind of do it from what we did before. This is the same as the 5th root of 2 to the 5th to the second power. This will cancel that out. So this will just become a 2, but then it's 2 squared, which is 4. Okay, so that's how we evaluate these. Now, this is how you do it by hand. Calculator is very helpful. You can probably do a lot of this a lot quicker with that. So for our purposes, I just want to show what's happening by hand. Okay, so this is a check for yourselves. So if you want to pause and try it here, you can try that one too. But for now, let's go ahead and look at a word problem with this. So the formula, m equals 512 minus 146,230, b to the negative 8/5, can be used to estimate the maximum total mass that a weightlifter mass b can lift using the snatch and the clean and jerk. According to the formula, was the maximum a weightlifter weighing 168 kilograms can lift. So this is going to be my b value. Okay, so I'm just gonna plug that in. So B is equal to 168. So that means M equals 512 minus 146,230 multiplied by 168 raised to the negative 8/5. Okay. From here, I am going to, let's see here. Well, if I do a little bit more by hand, I'm going to have to get to a spot with a calculator eventually, but I'm going to rewrite this with a positive exponent. So 168 to the 8/5 underneath. Okay. So that means M equal to 512 minus 146,230. And that's going to be the 5th root of 168 to the 8th power. Okay, so again, it'll be easier to do it this way. So I'm looking for a number times itself 5 times gives me 168. No, that's not going to be that one. I'm just going to get a decimal number from this anyway. So just use a calculator at this point. So let's see here, 146,230 divided by this one right here. Okay, raised to the units. Okay, so this is going to become M equals 512 minus 40.23. Okay, and then I just subtract those two. And I get the maximum amount that the weightlifter can lift will be 471.77 kilograms. Okay, so it's just a matter of working with this. It does not come out to an even number, so just use your calculator at that point. All right, since we're dealing with our exponents, all those properties from before still apply. So what that means is if I am multiplying with the same base here, then I can do the same as what we've done before. Geez, I can do addition between the two exponents. So this is the same as y to the 1/7 plus 4/7. So if I add those together, I get y to the 5/7. Now, in terms of simplifying, we may want to do this where we also write this as the 7th root of y to the 5th. Okay, just recognize that those are the same thing. All right. Simplify x to the negative 2/3. Kind of already did this. X to the negative 2/3 is the same as 1 over x to the 2/3. Okay. Which means that is the same as 1 over the cube root of x squared. Now, in terms of simplifying, we may want to actually do this where we get rid of the radical in the denominator. So if the goal is to rationalize it, remember if this is the cube root, I want this to be an x to the 3rd power. So I'm going to multiply it by the cube root of x to the numerator and the denominator. Okay, because what that does is this will now turn into 1 times the cube root of x, so it'll be cube root of x, and underneath it'll be the cube root of x to the 3rd, which that will just simplify to x. So we have the cube root of x over x. Okay, this is another one you can try it on your own, so feel free to pause it and give that a shot. And then you can pause that one and give that one a shot as well. And that is actually it for today. So again, we're dealing with our rational exponents, which means we're also dealing with a lot of those exponent properties that we've done in the past. Okay, the biggest thing about today is understanding that, go right back here. Okay, maybe. No, my screen's kind of frozen up, but just remember what it looks like. Okay, so if you're taking the fractional exponent, the new, up there we go. So my quick summary here, this is the biggest part of this today. So the number that's on the numerator is on the inside